Welcome to Module 2, Lesson 5, Graphs of Linear Systems and Inequalities. I first want you to ask yourself, what is a system of equations or a system of inequalities? Well, a system of equations is a set of two or more equations, and a system of inequalities is a set of two or more inequalities. So in the previous lessons, we were only looking at one equation or one inequality, and now we'll be looking at two at the same time. I'll start this lesson by showing you these three graphs and asking you, what do you notice and what do you wonder? Well, you may notice that in the first graph, we have two lines that intersect at one point. You may notice that in the second graph, we have two parallel lines that never intersect. And you may notice that in the third graph, we only have one line. But what if I told you it's actually the graph of two lines? So we're going to learn how to solve systems of equations. And I like to start by finding the solution on the graph, so that way you have a visual representation of what the solution actually is. So let's take a look at the first graph again. Since the lines intersect one time, this is an example of a system of equations that has one solution. In the second graph, since the lines are parallel and they never intersect, this is an example of a system of equations that has no solution. And back to graph number 3, I said, even though it looks like there's only one line on this graph, there's actually two. It's the graph of two of the same exact line, which means that the lines coincide and the two lines overlap each other the entire time. This is an example of a system of equations that has infinite solutions. So based on this, what can we conclude about where the solution to a system of equations lies on the graph? Well, the solution to a system of equations is the point of intersection, right? So since the lines meet only one time in the first graph, that means we have one solution, and our one solution is the point where the graphs meet, right? In the second graph, since the lines never intersect, that means there's no point of intersection, which means there is no solution. And in the third graph, since the lines lie on top of each other all the time, that means they are always intersecting, which means there are infinite solutions. So let's take a look at this graph here. We're going to write the equations to the system of equations, and we're going to identify the solution, right? So on the SAT, you'll be presented with some questions where they show you a graph of a system and they ask you to write the equations of the system, right? These are linear equations, so we're going to use our prior knowledge from the previous lessons to write the equations of this line, right? So recall the slope-intercept form, right? The two things we need to write an equation of a line is the slope and the y-intercept. So we'll start with this red line here. Let's find the y-intercept. That'll be our starting point, right? Our y-intercept is 1, 2, 3. So we know our b value is 3. Now let's find the slope by counting rise over run. So I'll start at our y-intercept and we'll rise 1, 2, and run 1. So that means our slope is 2 over 1, or just 2, right? So our slope, m, is 2. Our y-intercept, b, is 3. So if you substitute in the slope-intercept form, you get y equals 2x plus 3. Okay, great. Now let's look at the blue line, right? The y-intercept is the same here. So b will also be 3 for this line. Let's use rise over run to find our slope. I'll rise 2, and run 1. So you may think that the slope is 2 over 1. But remember from the previous lesson, I told you when you count your rise over run, make sure you check the direction of the line to determine whether your slope is positive or negative. Now we read a graph from left to right, and if we start at the left of the blue line and go to the right, the line is going down. That means that the slope is negative. So this time m will be -2, b will be 3, and we can substitute into the slope-intercept form, and our equation is y equals -2x plus 3. Now, what is the solution to this system of equations? Well, it's the point of intersection right here, right? So the coordinates for our point of intersection is 0, 3. Now, what's special about our solution for this specific system of equations? Well, what's special about it is that not only is it the point of intersection, but it's also the y-intercept for both of these graphs. Now I'll show you these two graphs here, and I'll ask you, how are they the same but different? Well, some similarities that I see is it looks like the lines are the same. It looks like they have the same slope and the same y-intercept. The differences that I see here is that in the first graph, it's just the graph of a line. In the second graph, our line is dashed and we have this red shading below the line. So the first graph is just the graph of a linear equation. The second graph is the graph of a linear inequality. Some rules to remember about the graphs of inequalities. So in our graph here, we do have a dashed line. There are several different cases that you'll see in a graph of linear inequalities. So if your graph has a solid line, right, that means the inequality symbol that's being used is either less than or equal to or greater than or equal to. So it's the equal to part that makes your line solid, right? Think about what type of line do we use to graph equations. Equations have an equal sign, right? And we use solid lines to graph linear equations, right? We use a solid line because we're using an equal sign, right? So when we have less than or equal to or greater than or equal to, we'll use a solid line to graph the inequality. A dashed line is used for inequalities that include less than or greater than. This indicates that our inequality is not equal to. Now, you may notice this red shading, right? The red shading is below the line. So the shading is what's going to represent the solution set. And if the shading occurs below the line, that means we're using less than or equal to. If the shading was to occur above the line, that would mean that we're using greater than or equal to. Our solution set, remember that inequalities have a solution set, right? It's not just one solution, it's a set of solutions. Our solution set is the entire shaded region. But note, if a point lies on a dashed line, it's not part of the solution set, right? Because that dashed line indicates not equal to, meaning any point on a dashed line is not included in the solution set. Now let's take a look at the graphs of systems of linear inequalities, right? So we're looking at two linear inequalities at the same time, right? Notice how we have a solid line and we have a dashed line, right? We have some shading below the line and some shading above the line. So the solution set to a system of linear inequalities is the area where the shadings overlap. This is the set of all points that satisfy both inequalities, right? our solution set to the system is all the points that satisfy both the inequalities, not just one, right? So over here, this section over here is where the red and the blue shadings overlap, and that's our solution set to the system of inequalities. So let's take a look at some points on this graph that are part of the solution set and not part of the solution set. So this point right here, it's part of the solution set because it lies in the area where the shadings overlap. This point on the blue solid line is also part of the solution set. Notice how it lies on the border of the area where the shadings overlap, and it's also on a solid line, right? Solid line means it's included, it's equal to. So since it's on a solid line and on the border of the solution set, it is also part of the solution set. This point right here is not part of the solution set, right? It's not part of any of the shaded areas. This point is not part of the solution set. It's only a solution to the red inequality, right? Not to the system of linear inequalities. And this point right here is not part of the solution set either. Now, it is on the border of the area where the shadings overlap. And it is also the point of intersection. However, notice how, while it does lie on the blue solid line, it also lies on the red dashed line. And if a point lies on a dashed line, it is not part of the solution set no matter what. Please pause this video and work on the Lesson 5, Level 1 problems in the workbook. Moving on to our Level 2 intermediate problems. We have a system of equations graphed on the set of axes. Write the equations for the system. What is the solution? Right, so there are two parts to this question. We need to write the equations for the system and then identify the solution. So just like we did in level 1, we're going to use our slope and our y-intercept to write the equations. So I'll start with this line here, this one that has a negative slope, right? I can tell that it has a negative slope because going from left to right, the line is going down. So starting with our y-intercept, it looks like our y-intercept is at 1, 2, 3, 4. So b will be equal to 4. We'll use that as our starting point to count our rise over run. So let's see. We'll rise 1 and run 1, 2. So that means our slope is negative 1/2. Our y-intercept is 4, so substituting into the slope-intercept form, we get y equals 1/2 x plus 4. In the second line, our y-intercept is at 1, 2, 3, 4, so negative 4 because we went down from the origin. So b will be negative 4. Let's count our rise over run. 1, 2, 3, 1, 2. So our slope is 3 over 2, and it's positive because moving from left to right, the line is going up. So then we'll just substitute into our slope-intercept form, and we get y equals 3 over 2x minus 4. Now, what is the solution to this system? Again, the solution lies on the point of intersection right here. So let's find the coordinates for our point of intersection. 1, 2, 3, 4. So x is 4, 1, 2, y is 2. Our solution is 4, 2. Right? Notice how when we solved linear equations, we only needed a value for x, or for one variable, to find our solution. For a system of equations, our solution will have an X and a Y value because it represents a point on a graph. This is something really important to remember when we get to the next lesson where you have to solve algebraically. You have to remember that you're solving for an X value as well as a Y value. Let's take a look at this multiple choice question. Which graph represents the solution of y is less than or equal to x plus 3 and y is greater than or equal to negative 2x minus 2? So we're going to use some testing strategies to cancel out some of the 4 options that we know can't be true, right? So lucky for us, it looks like each of the 4 graphs have 2 of the same lines. So we don't have to worry about finding the y-intercept and the slope for each of the 4 options. They all have the same slope and the same y-intercept. We really just have to look at the shading of the graphs to determine which one is the correct answer. So let's start with choice number 1. This first graph with a positive slope, it has a y-intercept of 1, 2, 3. So I know this graph represents the first inequality, x plus 3. Now, I know that y is less than or equal to x plus 3. So the shading should be below this line. But in choice number 1, the shading is above x plus 3, right? So we know number 1 can't be it. Now, I also noticed similarly in choice number 4, the shading is also above this line, right? So for the same reasons, it can't be choice number 4. So looking at choice number 2 now, the shading is below x plus 3, right? But it's also below negative 2x minus 2. So the answer has to be 3. And that's because if we look at x plus 3, we have our shading below the line, which is our less than or equal to symbol. And in negative 2x minus 2, our shading is above the line, which represents greater than or equal to. Please pause this video and work on the Lesson 5 Level 2 problems in the workbook. Moving on to level 3, our expert level. The graph of a line in the xy plane has a slope of 4 and contains the point 1, negative 5. The graph of a second line passes through the points 0, 4, and 12, 0. If the 2 lines intersect at the point AB, what is the value of A minus B? Okay, so we have a lot going on here. We know that we have the graph of 2 lines, which means that we're working with a system of equations. They're saying that the 2 lines intersect at the point AB, right? That means AB is the solution, and A will be our x value, and B will be our y value. They want to know what the value of A minus B is. So we'll have to solve the system first for A and B, right? And then substitute into A minus B. So we don't have a graph here and we don't have the equations here, right? So we're going to have to use the information that we're given and our prior knowledge from the previous lessons to write the equations for both lines. Let's take a look at the first one. They tell us it has a slope of 4 and contains the point 1, negative 5. Right? So notice how we have a point and a slope. So we can use the point slope form to write the equation of this line, right? And then we can rearrange it to put it into slope intercept form. So we're just going to substitute 4 for m, 1 for x1, and negative 5 for y1. Right? So we get y minus negative 5 equals 4 times the difference of x and 1. We can clean this up because y minus negative 5 is just y plus 5, and then we'll use the distributive property on the other side and get 4x minus 4. Now let's solve this equation for y so we can put it into slope-intercept form. We subtract 5 on both sides, and we get y equals 4x minus 9. Now let's write the second equation. So what they tell us about the second equation is that it passes through the points 0, 4, and 12, 0. So we have two ordered pairs, and we can use the slope formula to find the slope first. So substituting into the slope formula, we get 0 minus 4 over 12 minus 0, which is negative 4 over 12, which reduces to negative 1/3. Now we need the y-intercept, but if you notice, we already have the y-intercept. One of the points that they give us is the y-intercept, 0, 4. So if you remember from our previous lesson, the y-intercept always has an x-coordinate of 0. So 0, 4 is our y-intercept, and b is equal to 4. And now we can substitute into the slope-intercept form, and we get y is equal to negative 1/3 x plus 4. So now there are two ways you can get the solution here. If you're using the graphing calculator, you could put each of these equations into y equals and find the point of intersection. You can also solve this algebraically, right? So if the solution is where the two lines meet, it's where the two equations are equal to each other. So we'll set the equations equal to each other and solve. So setting the equations equal to each other, we get 4x minus 9 equals negative 1/3 x plus 4. We'll add 1/3 x to both sides and get 13 over 3x equals 13. Now we'll divide both sides by 13 over 3. Remember, dividing by a fraction means multiplying by the reciprocal, and we get x equals 3. So now remember, we're not done yet, right? We're solving a system, so that means we need an x value and a y value. We have our x value, and now we need to find our y value. So you'll choose either of the two equations and substitute 3 for x. Right, I chose the first one, but for the second one, you'll get the same answer. So substituting 3 for x, we get y equals 4 times 3 minus 9, so y is equal to 3. So that means a is equal to 3 and b is equal to 3. They want us to find the value of a minus b, so we'll just substitute in. A minus b equals 3 minus 3, which is 0. Please pause this video and work on the Lesson 5 Level 3 problems in the workbook. Once you're finished with the problems in the workbook, please stop this video and move on to the next video for Lesson 6.